All right, I'm going to go through part one of the summer assignment, and I want you guys to give yourself a score out of 42. You'll see kind of what the general point values are as we go, and I'll try to highlight some of the main ideas. The graphing and linearization of data is super important as part of the AP curriculum. You'll typically, one of the questions on the AP exam will be to analyze data. So we'll be doing this throughout the year. So the skills that you're learning over the summer, and we are going to use these throughout the year. So it's not something that's kind of a one and done. This is just a basic review from the reading, the graphical methods reading. So if any of this doesn't make sense, go back and read it. First column here is just asking you, what does this graph look like? So that if you have data that has this general shape and you're, again, plotting points and has this kind of decreasing slope shape, that's an inverse relationship. Now, the goal in physics with what we're going to learn is we want to be able to linearize that data, which is basically what do we need to do to our data set in order to get a straight line. So if we have an inverse relationship, we need to have an inverse on one of these axes. So in the reading, typically we invert the x-axis, but it is equally correct to have 1 over y over here, but we kind of have a general, like, mathematically correct versus what's correct for physics. So either way, it's all good. So I'm going to have to graph y versus 1 over x. And again, equivalent would also get you the point. But the big part is if I want to look at the graph and, again, eventually evaluate the slope of this line, whatever is on our y-axis, this is a variable. M represents the slope of the line, which is going to be this constant value because we have a straight line graph. 1 over x is now the new variable on the x-axis, and then b is our y-intercept. So 4 points, 1 point for each one of these. Did you get it correct? Top opening parabola, you're going to square the x-axis. And yes, it is equivalent to take the square root of y versus x. But I'm going to tell you right now, although that is mathematically correct, typically when we start to analyze the value of this slope, it is more intuitive to have squares instead of square root, because we're going to be looking at the units that are associated with this slope value to get some intuition as to what is going on. So it's more intuitively obvious when we look at square values than looking at square root units. It's just not as easy to look at. Anyway, 4 points for this one. And then side opening parabola, we're going to square the y-axis versus x. Again, you could have a square root down here. But typically, if we're looking at these graphs right here, this is what we want to do, and not focus too much on what the mathematical equivalent is. Focus on kind of these are the ones, kind of our go-to equations. So 12 points on this page, and we'll move on to the next page. All right. Again, if you have any questions, you can add comments to this and I'll come back to it and answer your questions. The next 3 problems ask you to graph data and analyze it. And there is a very specific way that we do this in AP Physics class. And we want to make sure that we're following all the steps, because graphing data should be pretty much an easy thing to look at. We just want to make sure that we're, let me get my good color here. We want to make sure that we're doing it correctly, because I think these are kind of easy points that you can get on a graph. So we're looking at, and the instructions tell you which one to put on which axes. So please make sure that you follow the direction, and you should have height on your vertical axis, and you should have this value, the shape factor, I guess you want to call it, on the x-axis. So graphing the data points. The first thing we're going to look for, the first point that you're usually given, is that you've labeled it, that you've labeled this axis B and you've labeled that axis H. 1 point. Units on the axis. B does not have any units, so there shouldn't be any. H is in meters. And then this point is a real tricky point, the best fit line. And AP graders are really specific about having the proper best fit line. First, it needs to be straight. You need to use a ruler. And I'm not kidding about this, because as a reader myself, I was asked to hold a ruler up to students' lines to see if they were straight. So don't lose this point because of best fit line. Best fit line also means that the points kind of alternate. They're not all on one side, and that this gap between the line is about equal on both. I would say my line is okay. It's very borderline. Actually, I probably would shift it down a little bit parallel this way so that the the difference, the space between your point and your line, but close enough. 1 point for that. And then this idea that it has to be scaled. So scaled means that your data points make up at least half the graph. So if I kind of box out the data points that I've used here, graph this right here, I've used about half the graph, and you would get that point. So you have to make sure that it's scaled, that you have a proper scale, that it goes by even increments. You don't jump around by points. So each, in my case, each 2 boxes is worth 0.1, and each 5 box is 0.05. So you're consistent all along the way. Okay, next is calculating the slope. And right now I'm going to have you guys just do this by hand. Again, we'll talk about how to do this with a calculator and using linear regressions a little bit later. You can always check your work with your calculator and doing a linear regression on the data points. But for now, we're doing this by hand. So first, you needed to circle the data point. That was the instruction. They should be points on the line, not data points. So if you pick this point and tried to calculate the slope with those two, you're going to lose that point. You could probably get away with using this point because it's kind of touching the line, and that point, that would be okay. But in general, I like to pick points that go right through the crosshair. So this is a good point right there, and then this one would be another good point right there. So I used these 2 points because they fell right on nice even points on my line. So show the calculation. Even if your line passes through 0, 0, 0, and you use it, you want to make sure, there's no 0, 0 on this graph, but in the future, you want to make sure that you show both y2 and y1, x2 and x1. So does your graph need to start at 0, 0? No, not necessarily. They're more concerned about that you are using the whole space to show your data. Basically, the idea with the graph is they're testing your communication skills. Are you able to communicate effectively the results of your experiment? If you graph all your data points in this tiny little box right here, you can't really see what the relationship is between the data. So that's what they're testing. There's not so much physics here. It's about communication skills. All right, so showing the calculation and then getting an answer that is in this range right here. So 1 point for circle the data points, 1 point for showing the calculation, and then your third point is going to be for your final answer right here, if it's in that range. And then there's just follow-up questions, and this is just basically reading the number off the graph and that it's consistent with your graph and your line. So the number, if you didn't draw a line, there's no way you can get this point. So you had to make sure you had a line there. So 8 points for the next page, page 3. All right, so moving on to page 4. Here's now we start getting into data that we need to linearize. So graphing the data, label your axes with units. So this should have T in seconds, and this one should be H in meters. And they're again giving it the directions, tell you which one to put on the Y and the X. So if you did not follow the directions, you're going to take off 1 point and then just give yourself the rest of the points. All right, it should be a smooth curve. This is not going to be a straight line. If you try to draw a straight line through this data, it would not be a best fit line. The best representation of this data is a concave up parabola. And again, next point is going to have at least half the graph is being used. So again, my data points, if I look at all my data points, I've graphed all the way up to here. If I look at that general section of the data of the graph, I've used more than half the graph. All right, so if I have this parabola and I want to now, typically what variables would I graph in order to get a straight line graph? So if I want to get something that's going to look like this, then I have to square the x-axis, so h versus t squared. So 1 point for each one of those. All right, that's a total of 5 points on that page. Calculating t squared, and again, square root of h is mathematically correct, and you can give yourself credit for it, but I'm going to tell you it's going to be easier if you just square things and not do square roots. Plot the data points, again, label the axes with units. So again, we have t squared and seconds squared. So whatever you do to the time axis also happens to the units. So that's part of that first point with the units, and then h versus m. So if you got part of this, it has to be, it's all or nothing. 1 point for both of these things. Best fit line, again, should be straight. It should pass through the data points and see that the data points are kind of alternating. This is a pretty good best fit line. That one's okay. And then half the graph is used. Circle the points. So I didn't add a point for that, but you should be circling them. Show the calculation is worth a point, and then you should have a value somewhere between 4.6 and 5.7. So when I did this linear regression of this data on my calculator, I got 5.1. So I'm asking you guys to do this by hand. So I want to see this done by hand. Again, this is what I'm testing this skill. Can you do this by hand? All right, so then we got next page, last question here. And I believe I correct this on yours. So this should be speed in meters per second and position in meters. And you're asked to put that on speed in the vertical axis and the position on the x-axis. Graph the data points, and you're going to see a side opening parabola. It should be labeled both smooth, decreasing, positive slope, 1 point. Half the graph is used, 1 point. So again, if you did squishy data and you've lost the points, don't get overly concerned about the grade right now. There's going to be a lot of points out there, so don't get too concerned about it. All right, now if I want to linearize this data, I want to square the y-axis. Again, equivalent, you could take the square root of x, but you're going to find that to be more challenging in the future. But for now, give yourself the points. V squared versus x is perfectly okay. 5 points on this page. And then we get into the last page here. So how square the data, or if you did a square root h, give yourself 1 point. Either way, you should end up with data that should look like a straight line now. You have linearized it. Label the axes, so pay careful attention to the units. Position was unchanged. We squared the y-axis, so we have v squared, and then the units are meters squared over second squared. Again, if you messed up the unit, you lose the point. Best fit line, talked about it, and then at least half the graph is used. Again, circle the points. Again, I found 2 points that were kind of nice. In this case, I didn't really know that any of these data points were on my best fit line, but again, it depends how you drew your data. Show the calculation, 1 point, and then you should have some range between 0.15 and 0.21, and then the units should be meters per second squared. So if I look at my units here, it's meters over seconds, whole thing squared. That's my y-axis, and my x-axis is meters. And one of these meters is going to cancel with one of those meters. So I have meters over seconds squared. All right, so that is the total. So give yourself a score out of 42. Again, if you made kind of consistent mistakes, now you know. And we want to make sure that we do the graphing part correctly, because this is something we're going to be doing throughout the year.